Hello viewers, in today's class we are going to discuss another problem from integrals, right? And in this lecture we'll solve a very nice integral in which we are going to use the concept of beta and gamma functions, right? So viewers, this integral can also be solved by the method of residues, right? Or by contour integration. But here we'll make use of the concept of beta and gamma functions. So let us take this integral as I, right? Now see here what we will do, we'll first write this integral as 2 times 0 to infinity 1 over x square plus 1 cube, right? So here we have used an important property of definite integrals, that is minus a to a f of x dx is equal to 2 times 0 to a f of x dx, provided f of x is an even function, right? So whenever f of x is an even function, then minus a to a f of x dx can be written as 2 times the integral 0 to a f of x dx, right? So f of x is an even function. It implies that f of minus x is equal to f of x, right? So here our integral is from minus infinity to infinity 1 over x square plus 1 whole cube, and f of x is 1 over x square plus 1 whole cube, right? So when we replace x by minus x, then f of minus x is equal to 1 over x square plus 1 whole cube, because here minus x square remains the same as x square, right? So f of minus x is equal to f of x. So we can write this integral as 2 times 0 to infinity 1 over x square plus 1 whole cube. So now let us apply the method of substitution, right? So here I will make this substitution, that is x square is equal to t, right? So we'll take x square is equal to t, or in other words we can say x is equal to square root of t, right? Now see, x varies from 0 to infinity. So when x is 0, then the value of t can be obtained from this relation. So we have t is equal to 0, and when x tends to infinity, then t also tends to infinity, right? Now x is equal to square root of t, so differentiating x with respect to t, we have dx over dt. The derivative of square root of t is 1 over 2 times square root of t, right? So now dx can be written as dt divided by 2 square root of t. So now this integral I can be written as 2 times 0 to infinity, and dx can be replaced by dt over 2 square root of t, and in the denominator we have x square plus 1 whole cube. X square is t, so we have t plus 1 cube, right? So here this 2 and this 2 get cancelled, so we have 0 to infinity, and here we have dt over square root of t, and here we have t plus 1 whole cube, right? So let us write this integral as t raised to minus half dt, and here we have t plus 1 cube, right? So now let us express or rewrite this integral as 0 to infinity t raised to minus half, right? So we can write minus half as half minus 1, right? And t plus 1 cube can be written as half plus, here we can write 5 over 2, right? So what we have done here, we have expressed this 3 as half plus 5 by 2. because 5 plus 1 is 6, 6 over 2 is 3, right? And minus half as half minus 1, right? So why we have expressed this integral like this? Because here we'll use the concept of beta function. So viewers, the beta function is defined as beta of mn is equal to the integral 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n, and here we have dx, right? So now if we compare this integral with this one, then here the variable is x and here the variable is t, and the variable is not going to make any difference because it is a dummy variable. So here we have m minus 1 and here we have half minus 1, right? So the value of m is half, and here we have 1 plus x raised to m plus n. Here we have 1 plus t, because t plus 1 can be written as 1 plus t, and this is half plus 5 by 2, right? So the value of n is equal to 5 by 2, right? So now this integral I is equal to beta of mn. M is half and n is 5 by 2. So this is half comma 5 by 2, right? Now we know an important relation between beta function and gamma function. So beta of m comma n is gamma of m, gamma of n divided by gamma of m plus n, right? So here I is now equal to gamma of half, gamma of 5 by 2 divided by gamma of half plus 5 by 2, right? So here we have m plus n. So this is gamma of half, gamma of 5 by 2, and here we have half plus 5 by 2, that is equal to 3. So here we have gamma of 3, right? So now we have to find the value of gamma of half and gamma of 5 by 2, right? Now see, we know that gamma of half is equal to square root of pi, right? And gamma of 5 by 2 can be written as gamma of 3 by 2 plus 1, because 3 by 2 plus 1 is 5 by 2. So this is 3 by 2 gamma of 3 by 2, right? Because we know that gamma of n plus 1 is equal to n times gamma of n, right? So n is 3 by 2. Again, we can split 3 by 2 as half plus 1 and applying this rule again. So we have 3 by 2. Here we have half, gamma of half. So this is 3 by 4 times square root of pi, right? So now taking these values in this expression, we have square root of pi times 3 by 4 root pi, and in the denominator we have gamma of 3. Gamma of 3 is equal to 2 factorial, right? So 2 factorial is 2. So here we have 2, right? So this is 3 pi over 8, right? Because root pi times root pi is pi, and here 2 fours are 8. So the value of this integral is equal to 3 pi over 8.